Hey guys, today in this video we're gonna cover the knife base. Welcome to my channel, and here we will upload a series of all videos related to machine learning and AI. And in this particular video we will cover the all things related to knife base. So let's start. Let's get into this. So first of all, in this video, what we gonna cover in this section? So in this section, we will cover three things. First is introduction to knife base, and which is somehow some sort of introduction lecture where we will study the working of knife base, and we will understand when and where we should use knife base and why this is really important, and what kind of ideas we can obtain, we can extract by this model. And second is implementation of naive Bayes in Python. We are not gonna cover R. We will only talk about Python, and we will implement the naive Bayes in Python, and we will see how we will implement naive Bayes on Python. And third is evaluation of the model, because this is really a fundamental part, and no one talk about this, because this is not enough. You learn the syntax, you train the naive base model, you train model, you test model. This is not enough. How can we improve that model? This is also that much important, and we're gonna cover that in third section. Okay, so first of all, let's don't get straight away naive base. First of all, we have to think about the working and what those naive and base words come from. So let's start with that. So first of all, we will see the Bayes theorem, because naive a base is made up of naive and base. Base is base shows this is Bayes theorem somehow, and naive shows that we have some less experience or something like that. We will see why it called as naive. So we will see that later on. So first of all, let's start the Bayes theorem. So in Bayes theorem, suppose we have spanner. This is a spanner, and suppose we have two factories. Factories one, we have two machines. Sorry, we have two machines. Machine one also creates spanner. Machine two also creates spanner, and we have labeled those spanner with M1, M2, which shows that this spanner is made by machine one and this spanner made by machine two. This is really that simple. And suppose sold all those spanner, and suppose we sold all those spanner, and now we got one spanner and that is defective. So what is the probability that defective spanner comes by machine 2? So this is really very simple. So this is somehow like, in Bayes theorem we find the probability of something when happened, and then, so if you don't know about Bayes theorem, you can check out your 12th standard book, maths book, or you can just find some example on Google or somewhere like that. So suppose we are not gonna, what is the probability that defective spanner comes from machine 1 and defective spanner come from machine 2? Suppose we have two machines, both machines create spanner, and we got a spanner and that is defective. So how can we decide that that defective spanner made by machine 1 or machine 2? So here Bayes theorem comes in light. So what we do, that we calculate the probability that the defective spanner made by machine 1, and we also calculate the probability that defective spanner made by machine 2. And now what we do, we compare which probability is greater. Suppose the machine 2, suppose the probability that that defective spanner is made by machine 2 is greater than the probability that defective spanner is made by machine 1, then we can say that the defective spanner is made by machine 2. And we have got this formula. It looks really very familiar. If you have studied some maths book, we have studied some probability before this, like before, so you will find this formula very, you will find this formula very familiar. Now how to remember, there is a trick, and I will just point out that trick. Suppose what you gonna do, suppose if this is in right side, you have to multiply with this, and this part is here right side, you have to divide with this. This is somehow you have to learn, you have to remember. This is some sort of thumb rule, you can remember this formula, suppose. And what we have decided here, suppose our defective spanner, we got suppose we have two spanner, suppose we have many spanner and we got one spanner defective. So what we will do, we will calculate the probability that the defective spanner comes from machine 1, and what we will do again, we will calculate the probability that defective spanner come from machine 2, and then we will compare these two probabilities. And how we will calculate this, we have here, if you see here, what we have to put some values here. Suppose we have already calculated that what is the probability that the machine 1 produce defective item. Suppose if machine 1 is very old, then it will produce more defective spanner, so the probability of defective when machine 1 will be higher, the probability of defective will be higher if machine 1 will be old. And we have to plug some this multiply with this value and then divide with be defective, because you can here again, if you just notice here, this machine 1, it means that the defective, this means the probability of defective spanner if we have selected machine 1. Okay, this means that, so we will multiply with this machine 1 and then we have defective. So this is really that means simple. You have to find and then you have to compare, and you can make a decision that the defective spanner come from machine 1 or machine 2. So what kind of naive Bayes model is, like where to use naive Bayes? Suppose we have filtered out some message, like in my phone. Suppose in my phone, if I open my inbox and I will get some spam messages. So I got here I got some spam messages, like all those messages come from company or some real estate business, which I really don't need, that are totally spam messages. And suppose in my inbox I got some normal messages, and here I have some normal messages. So what I did, I collected total 13 messages in my inbox. I had total 13 messages in my inbox, and out of 5 messages here, out of total 5 messages were spam, as you can see here, and total 8 messages were my normal messages, which come from my friend, family, like that. So now from here we can calculate the probability of spam, like probability of spam message. So I have calculated 5 by 13, and probability of normal message, it is 8 by 13, because I have 8 normal messages and we have 5 spam messages. It's really the training data. And suppose we have a model and we have to suppose we have a model, and what we want to make a model which can detect whether this is spam message and this is normal messages. Suppose our model is something like that, that it can detect the spam message, it can detect the normal message, and if it is spam message, it will put that message in block list, or if it is normal message, then it will keep that message safe. So what is the real thing about naive Bayes? So it is something like that. It basically, naive Bayes, what it does, it calculates the conditional probability according to Bayes theorem, and then calculate or compare What naive Bayes does, it calculates the probability of happening something. If some, suppose if it, what naive Bayes does, it calculates the probability of happening of A when event E has occurred, and it compare with the second thing, like it calculate the probability of two things and then compare. If probability of A is greater, then it, naive Bayes will say that A is our output, something like that. Suppose we have got the messages, we had two type of messages. In my phone I have spam messages and I had normal messages. What I did, in my spam messages, what I did, I had total 5 spam messages and 8 normal messages. So I wish to create a model which can detect spam message and normal message automatically. So what I did, I filtered out some common keywords which belongs to those messages, which belongs to both messages. Suppose I filtered out some message like dear friend, money, and suppose lunch. These 4 keyword I found in both messages. These 4 keyword I found in both messages. Okay, what I will do, uh, I just figure out all those 4 messages which is common in both. We can also take those messages which is not common. Suppose in spam messages there should be something called a discount or something more than that, something discount, real estate. These keywords will be more probable to come in spam messages. We can also take out that, but I will show you what we will do in that point. Suppose we have taken out dear friend, money, lunch, which was common in both type of messages. And what I did now, look at this. Hmm, just hang on. So what I did, I made a histogram for visualization. This is really I made for visualization. I made a histogram for spam messages here. If I take a pen, I can take a pen here. Suppose what I did, I made a histogram for spam messages and I made a histogram for normal messages. So in my spam messages, you can see that friend word come for 5 times, dear word comes for 7 times, and money word come for 9 times because it's really spam and they are demanding for money and something. And lunch word comes for 4 times. But if it's my normal message, you can see that someone says me dear many times and friend many times, and money is really very low because this is not spam message. And money comes for only 2 times and lunch comes for 5 times if someone is asking for me to lunch or some dinner, something like that. So this is histogram. And what I did, I calculated the probability that probability of coming friend if message was spam, and I will read it. Probability of word dear if message was spam. So I calculated all the probability, and it's really simple. We have total. If I just count in my spam message, I had, if you just plus every keyword, 9 plus 4 plus 7 plus 5, and we will get 25. And I have calculated the probability of word dear come if spam message it was, and probability of money if the message was spam, and we have calculated that right here. And the probability of the word lunch if our message was spam, we have calculated right here, as you can see here. So now here we have performed the same thing here. We have calculated the probability if word friend come if the message was normal, probability of word dear if the message was normal, probability of money if the message was normal. And how this 24 comes from, like we have added 8 plus 9 plus 2 plus 5. So I think up to here everything is clear. Now let's move on the next slide. Okay, so what I did, suppose it has, I has here inbox, I have here an inbox, and this is suppose my model, and I name it as naive Bayes model. I don't know what it does, but for now I will say that naive Bayes model will calculate the probability of words if message was spam, and probability of any given words if message was normal, and it will calculate the probability and then it will compare, and suppose if any probability greater, then it will say that this was spam or this was normal. So in my training data, and I have here 4 words. On the basis of these 4 words, naive Bayes will take decisions, right? And now I got a message, suppose I got a message, dear friend, this is Abhishek. And our model will feed only those keywords which we have already provided in training data. In training data, I have dear, money, lunch, and friend. So the naive Bayes model will extract dear word and friend word. And now it will calculate the probabilities. So it extracted dear and friend. Our naive Bayes model will extract dear and friend because it comes in inbox. Now what our naive Bayes model will do? It will calculate the probability of spam if the word friend and dear comes. And again it will calculate the probability of normal messages if the word friend and dear came, and it will compare those probabilities, these two probabilities it will compare. Now I have done something here. If I just okay, so how we will calculate this? Suppose I want to calculate this one, probability of spam if friend and dear keywords come. So what it will do, suppose first we have to write this in this way, p of friend dear if message was spam into probability of spam upon probability of the word friend and dear. And we will do the same thing for normal messages. We will do the same thing for calculating the probability for normal messages if the friend and dear keywords comes. And since why it is naive Bayes, now look at this. Since it is naive Bayes, we assume that all features are independent of each other, and hence we call it as naive. What does it mean? In real life, friend and dear is really correlated, because many times if we suppose we write dear, then it is more probable we will write friend, we will write mom, we will write dad. So we can say that dear and friend is correlated. If dear comes, then it is more probable that we will write friend or mom or something like that. So in real life this is really wrong. Friend and dear is not different thing. So we can say that friend and dear is somehow correlated. But what naive Bayes does, it assumes that friend and dear is not correlated. I can say this again. You have to keep in mind that in naive Bayes we assume that features are not correlated. And this is totally wrong. And that's why we say it as naive Bayes. We say it as naive Bayes because we somehow get the good results, and that's why we don't ignore this model still we say that this is naive because it is not considering any because it consider a assumption which is really naive, which is really unexperienced, and that's why we say that it's naive. Now come to the point, just don't talk about that. So here we will say that probability of friend and dear will be probability of friend into probability of dear, because we have assumed that friend and dear is totally different thing. They are not correlated, they are not dependent, they are really independent, we can say that. Now what we will do here, suppose we want to calculate the probability of spam if the friend and dear words comes. So here we have written the same expression, and this is really familiar to you, that we have written probability of friend if message was spam into probability of dear if message was spam into probability of spam upon probability of friend into probability of dear. So I have written the probabilities from the previous sheet here, so that we don't need to look at those previous sheet. So I have written those things here. Okay, now you can see that I have written those expressions here. Probability of friend when it was spam into probability of dear when message was spam into probability of spam into probability of trigger, and we have to just compare it. Okay, we have to just compare it. If the probability of spam if friend and dear words came is greater than probability of normal if friend and dear word came, then we will say that the message was spam because probability of spam is greater. Now we will cancel out these two values. Why? Because it comes in both expression, and that's why we will cancel out. And we can say if we are neglecting this denominator in comparison, we can say that we are just comparing likelihood. Okay, because the real probability, we will say this is real probability if we will divide it, but we are not dividing. For now we are just comparing it. So I have calculated here. I have provided values, you can plug it and you can also calculate, and I found it that probability of normal. Okay, just let's go back in this sheet. Okay, we calculated, you can also calculate. I have given these values and I have calculated that probability of normal message if the word friend and dear came is 0.07, and the probability of spam if the message was friend and dear is 0.02. And here we can take a decision that the message was normal, and we will retain that message, we will keep that message in my inbox, and the model will not delete that message. So this is something like that. This is naive Bayes. Why it comes in use? We can detect spam messages and dear we can detect spam messages, and we can use this model manywhere. Like we can use this model wherever we can predict some data, we can take some decision based on probability, we can use this model. And suppose I have just provided you this thing here. What you can do, suppose we have this long table. Suppose we have this long table, and they're given weather, and they're given play. It means that whether a student will play or not in this weather. Suppose it was sunny. Look at here. If it was sunny, the student did not play, and if it was sunny, the student didn't play. And this is my whole data set, and I have converted this in frequency table. So if you don't know how to convert this frequency table, then if you don't know how to convert this into frequency table, then you can remember that this is converted by pd dot cross yeah, pd dot cross type. You can convert this by pd dot cross type. Okay, so I have again calculated all these probability, and we can also take decisions on the basis of probabilities. Okay, so now we will look at Python, and now we will see how to implement our naive Bayes, and I will also demonstrate the model where we will be detecting our message as spam or it as normal messages. So stay tuned, and we will be covering that.